Okay, so we learned about graphing and linear equations. So now we're going to talk about substitution in systems. So we're going to have two equations. So the term system means two or more equations. And so you see here we have these two equations. And what we need to do is substitute these x, y values to see if what makes it true. Which is true? Which is true in both equations? And we did this with our last assignment, our last chapter. So here our y, remember this is x, y. So basically we're saying, I could just do this real quick, is 8 plus 2 equal to 6. That's false. So he's out. Okay, let's do the same thing. So 8 plus 2 is 10. Is that equal to negative 6? No. Let's try this one. Is negative 6 plus 8 equal to 2? Well, that makes more sense to me, so let's try it. Negative 6 plus 8 equals, it does equal 2. So this could be a possibility, maybe. So let's try it in the next equation. So 2 parentheses, how much is my x? Negative 6 parentheses, always substitute with parentheses, plus 2 equal negative 10? Yes. Yes and yes. So here's my answer. Okay, let's try this next one. So I could write them out. So 2 times 3 plus 1, that equals 7. And we say it's supposed to equal 1, so that's no. We could say 2 times 1 plus 1. By the way, that equals 7. So that's 2, that equals 3. Does it equal 3? It sure does. Let's try it on the second one. 4 times 1 minus 1. So 4 minus 1 is 3. That is also true. So here is my answer. Let's try the next one. Remember, these are my x and y's. So this one would be 3 minus 1 equals 4. It does not equal 6. He's out. Next one. Negative 1 minus 3. That's a negative 4. He's out. Negative 1 minus a negative 7. That's a negative 1 plus 7. Negative 1 plus 7. I think that equals 6. So that's a contender. Let's try the next one. 2 times negative 1 minus 5. So 2 times negative 1 is negative 2. Negative 2, take away 5 is negative 7. It didn't work. Let's see. 7 minus 1 equals 6. That's true. Let's try the second one. 2 times 7, 14, minus 5. Did I do that right? 2 times 7 is 14, minus 5. 14 minus 5 is not 1. So that's not it. Do I need to go back up here? Did I do this one wrong? Oh, I did, because there it is. Look at me. There you go. That's 2 mistakes I've made today. All right. So here's one way we would call substitution. You are substituting values in to see if they make it true. Another way is if you have an equation that has x equals or y equals, you can substitute that expression into another equation and solve. So again, you can also have infinitely many solutions. This is when your variables cancel each other out. And you're left with a true statement. A true statement would be 3 is equal to 3. Or 4 is greater than 3. It doesn't matter as long as that end statement is true. You would end up with no solutions when your variables cancel each other out and you're left with a false statement. And that would be like 3 is equal to 4. That's false. Or we'll say 17 is greater than 20. Those are false statements. If you end up with a false statement, you end up with a no solution. So let's put this into action. So when I say when something looks like y equals, this is specifically what I'm saying. So you're going to find your x and y coordinate. So in order to do so, I'm going to substitute this into, since this looks super simple, right here where that y is, and solve. So I'm going to say 2x plus 8 times 2 is equal to 20. And then solve that. 2x plus 16 equals 20. Minus 16 to both sides. 2x equals 4. Divide by 2 and x equals 2. So if x equals 2, and here, remember this is my x, my y also equals 2. Because that's what it told us. And that's our solution. So you have to find both this x and y. Let's go over here. It's given us the x, so we already know that x is going to be 5. Now we got to find that y. So I'm going to say 2 times 5 plus y equals 10. So 10 plus y equals 10. Minus 10 minus 10. Y is equal to 0. And that's okay. Next, we're going to make it a little more difficult. So now it's telling us that y is equal to 2x. So we're going to take this whole thing and put it where the y is. Because that's what it says. It's what y equals. So this is what it's going to look like. You're going to say 5x minus 2. Now we said y is equal to 2x, so I'm going to put that 2x here. And then continue with the equation equals 3. Simplify. Keep going. Ooh, I've got x equals 3. Now, how do I figure out the y? To find the y, it says y equals 2x. So y is equal to 2 times 3 because we found x. So my y is equal to 6. This is probably the hardest part of this, is the section of this chapter. So if you can get this, you're going to be pretty good. Okay, so they want us to substitute this where the x is, right here. So 2y plus 3y equals negative 15. 2y plus 3y is 5y equals negative 15. Divide by 5. Y is equal to a negative 3. Oh, I got y. Now I have to find the x. Well, here's the x. X is equal to 3 times my y. Or x is equal to 3 times, what's my y? Negative 3, which is negative 9. Now we're really getting more difficult. And when it gets difficult, well, there's two things here. So number 5 is getting a little more difficult because now you have this whole thing here. So you need to substitute this whole thing here. So 4x plus 7, instead of the y, we're going to put x plus 9 equals 19. So distribute. 4x plus 7, x plus 63 equals 19. Combine those like terms. 11x plus 63 equals 19. Subtract 63. 11x equals a negative 44. Divide by 11. So x is equal to a negative 4. So now I do have my x value. How do I find the y value? I'm going to use this equation here. So y is equal to that x value plus 9. So y is equal to 5. Now we have our x and our y. That's how you do it. And if you want to check yourself, you can always substitute these values back up into this equations, both of them. What this means is there is one solution to this equation, and that's what it is. So if you were to graph this, this is where your two lines would cross. Okay. Last one. Anytime you have a y equals and a y equals, set them equal to each other. We do this often in geometry. Set them equal to each other. So what do I mean? I'm going to say 6x plus 11 is equal to 2x plus 7. And then solve. Get my variables together. Subtract my constant. Divide, and I get x is equal to negative 1. X is equal to negative 1. Got it. That's one thing. Now I need to substitute that back into one of these equations, and it does not matter which one. I'm just going to go with this one, just randomly. So my y is equal to 2 times that x value of negative 1 plus 7. 2 times negative 1 is negative 2. Negative 2 plus 7 is a positive 5. So my ordered pair, or the solution to both of those equations where they would meet or cross if you graphed them, would be negative 1